we're going to do these in two parts. You already know the calculus. What optimization problems is, you're trying to find the maximum or minimum in a problem. Okay? And you know the calculus part of that. Basically, it's finding the derivative, making it equal to 0, correct? And taking that answer and plugging it into your original function, correct? Right? That's that's what we've been kind of working on for quite a while. So there are going to be certain words that are going to tell you you're finding the maximum or the minimum. They'll use words like largest, least, greatest, smallest. Okay, those words will be in the sentences. And what's going to happen is you're going to find what makes optimization problems hard is the setting up. That's the difficult part. And when you do that, you're going to end up coming up with usually two equations. One is going to be a function. So what we're going to do today is we're not going to be solving, we're just going to be working on setting them up. That's the most difficult. After you set them up, all you're going to do after that is calculus. Is everybody with me on that?
Yeah.
All right.
Just let me sharpen my pencil real quick.
Okay, so I'm flipping over here. So these are kind of the steps that I do. And we're only going to do these first two today. Nope, I'm wrong. First three. Most of the time you're going to draw a picture. You're going to write an equation that's being optimized. This is going to be your function. And then you're going to have another equation that you're going to have this function with a single variable. There isn't going to be two variables. You're not going to be doing the product rule, okay? Unless you have two different functions or something like that. So, the first problem I have here, there will be no pictures because we're just talking about two numbers. And so there are two parts here that says two numbers whose sum is 30. And then over here we have another sentence that says whose product is as large as possible. Notice right here is large. This is the one that's going to be a function. Why is it going to be a function? Because that's what we're going to find the maximum of. Because the word large says I want to know the maximum. I want to maximize this. I want to find the maximum point, the relative maximum point, or the absolute maximum point. It's going to be coming from a product. So the first thing I'm going to do is I'm going to come up with two numbers whose sum is 30. So here's my first number is x. Here's my other number, it's y. It equals 30. It's not a function. It's simply an equation. It's equal to a number. Over here, I'm going to have my function. I'm going to call it f of x. And it has to be a product of two numbers. So I'm going to call one of those numbers x, and the other number is y. Now there's a problem with this. When I write f of x, I'm saying I have to have a function that's totally in terms of x. And I've got a y in here. So I'm going to use this equation to get rid of that y. And how can I do that? Well, I can get y by itself, and this says, hey, if I subtract x, I get 30 minus x. So wherever I see a y, I can replace that with 30 minus x. So now my function becomes f of x equals x times 30 minus x, and I'm done. I now have gotten my function in terms of x. So I didn't have to draw a picture here. I wrote an equation that's to be optimized. That's f of x equals x times y, because I wanted the largest product possible. I had another equation, two numbers whose sum is 30. Its purpose is to get rid of that y and come up simply with a function in terms of x. Now we're going to do something with f of x down the road. We're going to take the derivative of f of x, but we're not going to do it today. We're just going to get to that far. Is that making sense to everybody? Okay. Right here, now there's a picture already here. This is the equation y equals the square root of x. And right here's the point 5, 0. And it says, what point on this graph is closest to 5, 0? Well, what I did is got my ruler and said, well, it looks pretty close if I draw this line right here. So here's the word closest. If I went way over here, it'd be further away, correct? I want this to be as small as possible. Do you agree? So I'm looking at the word minimize. Everybody okay with that? Now, see, and this is a problem with, that makes, I think, calculus difficult, is now, if I want something closer, I have to infer something. What am I talking about when I say, hey, I want to get something closer? I mean, closer is not a math term, is it? What do I want to make small?
The distance between the line and the point.
Yeah, it's a distance. Would you agree? So I'm going to call this my distance. Okay? And unlike this one where they actually tell you, take two numbers, add them together, make 30, multiply two numbers, make it as large as possible. Here I want this distance to be as small as possible, correct? I want to minimize that distance. Now, remember when I've also said what makes calculus difficult? Everything you've learned from kindergarten on, we use. So somewhere along the line, you came up with a distance formula. And it's really the Pythagorean theorem. You remember that?
Pythagorean theorem, yes, I do.
Okay, so I'm going to show you over here what I'm talking about. Let's say I have a right triangle. And right here I have a point, right here I have a point, right here I have a point. And I'm going to call this point right here x1. And I'm going to call this point right here, I'm going to call it x1, y1. And this one I'm going to call it, yeah, x1. I'm gonna call this one x1, y1. This is x1, this is y1. This right here is x2, y2. And I want to know this distance. That distance is a hypotenuse. I can come right here and say I gotta make a right triangle out of this. And this point is x2, because it's directly below this, and it's directly across this, x2, y1. So this distance, this horizontal distance, what would that be? From here to here. Yeah,
5.
how did you come up with 5?
Because the rest of it, because. The,
No, I'm not talking about this, I'm just talking about an arbitrary,
Oh, just
point.
making up random numbers.
yeah, well, okay, if I'm right here, and this, let's say this is 7 and this is 3, what would that distance be?
4.
4, would everybody agree? What if the distance was 9 and this distance was 1? What would that distance be?
8.
8, would you agree? How are they getting those numbers?
Subtracting them.
Okay, so what, if this is x2 and this is x1, what's that distance?
x2 minus x1.
It's x2 minus x1. That's the distance of that segment. What about this one?
Y2 minus Y1.
It's going to be y2 minus y1. Well, this distance is a hypotenuse, correct? What am I going to do with this distance to figure out this distance?
Square it.
I'm going to square it, aren't I? So I'm going to take x2 minus x1, square it. What about this distance? What am I going to do with it?
Square it.
Square it. And I'm going to have y2 minus y1 and square it. And then what do I do with them? I add them together. Is that my answer?
We add them together, then you give us the square root.
Then you take the square root of them. So we say that the distance formula is this, the square root of x2 minus x1 squared plus y2 minus y1 squared. Do you remember that now?
Yeah.
Okay. And we want to minimize this. I'm going to say that again. I want the closest distance. I want to minimize that. So I'm going to make it into a function. And I'm going to get rid of some things. I know this point right here. This point is 5, 0. Correct? This point I don't know. I can call it x, y. Everybody with me so far? So now I can say I have, and I can choose, one of these can be x1 one of these can be x2, it doesn't matter. So I'm gonna write x minus 5 squared. Here's the x value for this point, here's the x value for this point. Everybody with me so far? Plus y minus 0 squared. Here's the y value for this point, here's the y value for that point. Now, this is a function that since I put x, oops, I forgot my squared here. Everything has to be in terms of x. So I got x minus 5 squared. I got a y here. Can I get rid of that y and replace it with something? Bella, do you think so?
Probably.
What? What's another name for y in this problem?
F of x or d of x.
Pardon?
D of x.
Well, d of x is going to be the function I'm going to minimize, okay? But in here somewhere, I have said in my problem what y is all the time. And it's in the question. What?
Square root of x.
It's the square root of x, isn't it? So I can get rid of this y, and then I can say the square root of x minus 0 is what?
Square root of x.
And what do I get when I square the square root of x?
X.
I'm done. That's as far as I gotta get. Now, what was hard about this? It's probably been a while since you've talked about the distance formula, right? This is what we want to get to. This is what we're gonna take the derivative of later, not today. We just want to get to this part. Okay, this actually, number 3, is my favorite problem for a number of reasons. It's number 3, first of all. And secondly, it was one of my things that I had to do at Kruger Welding. I had to make little rectangular containers. Okay, and this is how we did it. We would get a piece of steel and make it into a rectangle and cut off the corners and then bend it up, because we had a certain thing that bends steel. And then where the sides would meet, then we would, we didn't weld, we brazed something, which is kind of like welding, but it's a little bit different. You use a torch and heat it up and you put a metal to seal it, okay? So this one says, Mr. Kelly needs to make an open box to store all of his magic cards. I don't know what those are. He has a piece of cardboard that is 14 by 30 inches. So I'm going to draw a rectangle, and I'm going to label it 14 over here and 30 over here. To do this, Mr. Kelly cuts out squares of equal size from the 4 corners so the corners can be bent upwards. So in other words, he's going to cut out a square here, he's going to cut out a square here, he's going to cut out a square here, and he's going to cut out a square here. And this, all those squares are the same. And that square is going to be x this way, 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 x this way. So it's going to end up looking like this. Let's see if I can draw a picture. Not a very good one. So those squares are gone. That making sense to everybody? And then it's going to be folded here, it's going to be folded here, it's going to be folded here, and it's going to be folded here. and it's gonna look like this. Everybody with me so far? Is my explanation okay? All right, now, notice it says this: what size should the squares be in order to create a box with the largest possible volume? Tyler, do I want to minimize or maximize? What is it I want to maximize?
Volume.
Volume. Volume of a rectangular prism, correct? Again, you probably haven't talked about volume since you were in geometry. And for some of you, that may have not been till you were 8th or 9th grade, correct? But unfortunately, you're required in the class to know how to figure out the volume of a rectangular prism.
Length times width times height.
Volume equals length times width times height. So that's what we got to get in terms of x. Does that make sense? It says volume. We want the largest volume when it want to maximize this. This has to be in terms of x. So I'm going to write
H equals X.
So I'm going to write down v of x here, right, as a function. Here's my length. Here's my width. Here's my height, correct? My rectangle was 14 for a width, correct? Here's my width right here. Is it 14 now? Why not?
Because you took little pieces off the side of it.
I took off how much off of this side?
X.
X, correct? And what about this side?
X.
So what's my width?
14 minus 2x.
14 minus 2x, and I'm gonna write that right in the middle. What's my length? That's this. It was 30. Is it 30 now? Is it still 30? No, a chunk has been removed here and a chunk's been removed here, hasn't it? So what is it?
30 minus 2x.
30 minus x. 30 minus 2x, correct? Is that what you said?
Yeah.
So here's my length, here's my width, I need a height. Yeah,
X.
x. Bam, I'm done. That's as far as you need to get today. That's the volume in terms of x. That's the function we're going to maximize. You doing okay? All right. Two towers are 30 feet apart, okay? One is 12 feet high, the other is 28 feet high. I can do that. Here's 12. Here's 28. Here's 30. It says there is a stake in the ground between the two towers. The top of each tower has a wire tied to it so that it connects to the stake on the ground. Where should the stake be placed to use the least amount of wire? Least amount of wire. Now,
Green theorem.
I have to put that in here, not necessarily in the middle. So I'm just gonna find a spot and put it here. Owen, you could put it here. You could put it here. You could put it here. It's not guaranteed to be in the middle. Everybody understand that? So this wire is coming down here, and this wire is coming down here. So this is the length of the wire. Everybody with me? Okay? It says, where should the stake be placed to have the least amount of wire? Well, let's say I'm gonna call this X. And that's where the stake should be placed. Do I know this length? Because that's a piece of the wire, right? Can I come up with a function or come up with an equation that tells me this length? Owen, what would it be?
You'd have to know where the stake is between the buildings, but then you just,
I know, but you don't know that.
or you don't.
No, but can I express this? This is 28 high, this is a distance of X here.
So it'd be like y squared plus 30 minus x squared. Am I looking at that right?
I think, well, you know what? Where are you, you know what, I'm not disagreeing with you. Where's 30 minus X?
The bottom.
Right here or right here?
Either or. No?
You're correct, but it's not either or. It could be either or, but because I'm telling the story, I made this X, right? Like if this was 5 feet, how much would it be on this side?
25.
25. If it was 10 feet, it'd be how much on this side?
20.
20. So since I decided, okay, that this is a distance of X, this has to be what distance on this side?
30 or x minus 30. No.
Which one is
It
it?
has to add up to x.
It has to add up to 30.
Yeah.
So what does it have to be? One of those was correct. So it was 5, this would be 25. If it was 10, this would be 20. If this was 15, this would be 15. If this was 29, this would be 1. How am I getting those numbers? I know they add up to 30. You were correct, and I think I confused you. That's what I think. Do you know what it is, Ariana?
Well, if the other side,
If this is X, what does this side have to be?
y,
It could be Y.
so.
It could be
minus
Z.
y.
So X plus Y equals 30. Is that what you're telling me?
Yeah.
And y equals 30 minus x.
And Y equals 30 minus X? Pete, would you agree with that? Okay. So X plus Y equals 30, and that would mean Y equals 30 minus X. Everybody okay with that? Okay, but here's the wire. What's that length? Matthew,
That y, which one? The one?
this one right here.
Oh, that'd be x squared plus 28 squared. The square root of them both. The other one would be the square root of x minus 30 squared plus 12 squared.
Where's he getting, okay, you're correct. I'm gonna back up.
I apologize.
Okay.
I just
Nope,
was really
I'm just
excited.
backing up to clarify everything you said here. Where does he get that from?
The distance formula,
Yeah, it's another, what's another name for it?
Pythagorean theorem.
Pythagorean theorem, correct? This side squared plus this side squared gives, the square of that gives you that hypotenuse, of which is part of that wire, correct? And then what did you say this side was? Another square root? Am I right?
Yes, that'll be a square root of 30 minus x squared plus 28 squared. Or is it 12?
What's this
12.
one? 12.
That wrote something down wrong. And you
So
add those
this
two things
length of this
together to get your
wire is
answer.
x squared plus 28 squared square root of. And then the length of this wire is 30 minus x squared plus 12 squared square root of. Would everybody agree? So, I'm gonna have a function. I'm gonna choose W. X is my input. It's going to be two square roots added together. 30 minus x squared plus 12 squared plus, that's this wire, square root of x squared plus 28 squared. We're not solving that, we're just making up. So this is the function that we are going to minimize. This represents the length of the wire. Okay. You'll see a lot of representations using the Pythagorean theorem, especially when it talks about distance. Does that make sense to everybody? Okay. So the problems I'm gonna give you are a lot like these. So you're gonna look at these notes and you say, okay, how did he come up with those? All right? You wanna end up with this as your answer in some, as a function of one variable.